Hello friends, I am Dr. Marathe. Today we will try to discuss about how the end product of glycolysis known as pyruvic acid, how it is converted into acetyl CoA before entering into the TCA cycle. So pyruvic acid, that is pyruvate, CH3 C double bond O COOH. How it is converted into acetyl CoA, that is CS3 C double bond O high energy bond SCOA. So this is pyruvic acid, this is acetyl CoA. But this is not a simple reaction. Actually, this requires the multi-enzyme complex for conversion into acetyl CoA. And that multi-enzyme complex is known as PDH complex. This multi-enzyme complex known as PDH complex, it is actually made up of three enzymes. One, it is known as pyruvate dehydrogenase. This is the first enzyme. Second enzyme, dihydrolipoyl transacetylase. This is the second enzyme of this multi-enzyme complex. And the third one is known as dihydrolipoyl dehydrogenase. Now these are the three enzymes of this multi-enzyme complex which are necessary for the conversion of pyruvic acid into acetyl CoA. But this multi-enzyme complex, they require the 5 cofactors. They require 5 cofactors to carry out these reactions. And these 5 cofactors are: number 1, it is known as TPP, known as thiamine pyrophosphate. Second one, it is lipomide. This is another cofactor required for this multi-enzyme complex. Third one is known as COASH, known as coenzyme A. Fourth one, known as FAD, that is flavin adenine dinucleotide. And the last cofactor, which is fifth cofactor necessary for this multi-enzyme complex to carry out the reaction, is known as NAD, nicotinamide adenine dinucleotide. So without these cofactors, this multi-enzyme complex cannot convert pyruvic acid into acetyl CoA. So they are essential part of this multi-enzyme complex. Now let us see how these three enzymes, by using the 5 cofactors, converts pyruvic acid into acetyl CoA, step by step. So first, pyruvic acid. Pyruvate is CS3 C double bond O COOH. This pyruvate, it is oxidatively decarboxylated, means carbon dioxide or carboxyl group, it is removed from this pyruvic acid. But it requires the first cofactor because the first enzyme works here, and that enzyme is known as PDH. PDH. We can simply call it as a pyruvate dehydrogenase. So this reaction is catalyzed by pyruvate dehydrogenase. And this pyruvate dehydrogenase then removes the carbon dioxide and whatever the group after removing carbon dioxide that remains, it is linked to thymine pyrophosphate. So this is called as hydroxy ethyl TPP. Hydroxy ethyl TPP. Now, second reaction, which is catalyzed by the enzyme dihydrolipoyl transacetylase. Dihydrolipoyl transacetylase. Simply, in a short form, I have written here DTS, dihydrolipoyl transacetylase. Okay. Now, this time it uses lipomide, as I said. This is oxidized lipomide. It is a coenzyme form of vitamin lipoic acid. This is S. Now this acetyl group, it is transferred by dihydrolipoyl transacetylase on the lipomide. So it becomes lipomide SH, as this bond is broken down, disulfide linkage is broken down, okay, and C double bond O CH3. Now this is acetyl lipomide. This is known as acetyl lipomide. In the subsequent reaction, which is catalyzed by the same enzyme, dihydrolipoyl transacetylase, but this time it uses another cofactor, and that cofactor is CoASH, that is coenzyme A. Okay. So the acetyl group from this acetyl lipomide, it is transferred on coenzyme A, and that becomes CH3 C double bond O high energy bond SCOA. And after removing this group, this SH is there, sorry. Okay, this SH is transferred on this one. Then this product is formed. We call it as a acetyl coenzyme A. But whatever the lipomide it was used, it was initially oxidized. Now, due to this reaction, it has been reduced. So we can write here lipomide SH. So this is the reduced form of lipomide. Now this reduced form of lipomide must be converted into oxidized. This is oxidized form of lipomide to complete the reaction. So to complete the reaction, then the third enzyme that works, that third enzyme from this multi-enzyme complex is known as dihydrolipoyl dehydrogenase. Simply I am writing here DDH, dihydrolipoyl dehydrogenase. So simply this reducing equivalents, they are transferred to FAD, which is the fourth cofactor utilized by this multi-enzyme complex, flavine adenine dinucleotide. And due to acceptance of these reducing equivalents, it is converted to FADH2. It is reduced to FADH2. And finally, last cofactor which is utilized by dihydrolipoyl dehydrogenase, along with this cofactor NAD plus, accepts these two reducing equivalents from FADH2 and itself get reduced to NADH plus H plus. Now whatever the NADH plus H plus it is formed, that NADH plus H plus by oxidative phosphorylation process transfers the electron to electron transport chain and it forms 3 ATPs from 1 NADH plus H plus. But as there are two pyruvic acid molecules, we have seen in a glycolysis when one glucose molecule it is converted into two molecules of acetyl CoA. So two molecules of acetyl CoA, two molecules of pyruvic acid, two molecules of pyruvic acid, they are converted to two molecules of acetyl CoA. So finally, again, two molecules of NADH plus H plus are formed, and these two molecules of NADH plus H plus, they donate their reducing equivalents to electron transport chain, forms 3 into 2 means 6 ATPs from this. So simply we can summarize this reaction so pyruvate CH3 C double bond O COOH plus NAD plus COASH, that is coenzyme A. Okay. By the enzyme, this is multi-enzyme complex which is made up of three enzymes, pyruvate dehydrogenase. It is converted into acetyl CoA, that is CH3 C double bond O SCOA plus, as decarboxylation reaction occurs, so carbonyl group is removed in the form of carbon dioxide, plus NADH plus H plus. Now this is the summarized reaction of how converted pyruvic acid is converted to acetyl CoA, and this requires pyruvate dehydrogenase complex. As I said, this pyruvate dehydrogenase complex, it is made up of three enzymes. Those are pyruvate dehydrogenase itself, dihydrolipoyl transacetylase, dihydrolipoyl dehydrogenase. So this PDH complex, it is present in the mitochondria, and there are 29 moles of pyruvate dehydrogenase, is 1 mole of dihydrolipoyl transacetylase, and 8 moles of dihydrolipoyl dehydrogenase. So finally, acetyl CoA is formed. Now that acetyl CoA then enters into the TCA cycle through oxalo acetate and it forms a citrate. Okay, thank you.